Find the volume of the shape created by revolving the curves y equals x squared and y equals cubed, but the y-axis as shown to the right, for 0 less than 1. 0 less than y less than 1. Okay, so this is what I like to call the disk minus disk method. So what we're going to do is we're going to find the... so this is going to be revolved about the y-axis. So I have something kind of like this. I know it's terrible, but the same thing is here, just reflected over. And then we will find the area of one disk, and we'll subtract out of it the area of the interior disk, like so. And now leave us with just this area right there. And this is going to be a thickness of delta y. So when we write this equation out, we're going to do it like so. So I like to do is pi r big squared minus r small squared delta y. And we'll go from 0 to 1. And we know it's going to be 1 because x squared equals x cubed at x equals 1. X equals 1, y equals 1. Everything else equals 1 at 1 in this case. Okay, focus. So we're going to integrate from 0 to y equals 1. So we're going to integrate up. Now allow us to use the disk method. Whenever you are, your radius is to the, I guess, perpendicular to the direction that you are integrating. So our radius here for these will be to the right along the x-axis, and we're integrating to the y direction. That will almost always, pretty much always, be using the disk method, where you have pi r squared. But since we're doing one disk minus the other disk, this is actually pi r squared minus pi r squared, where one r is big, one r is small, and I just factored out the pi. So this is the equation that we're going to use. And the trick then becomes finding out what these radiuses are. Radii. What these radii are. Sorry, I don't mean to misname my radii. Okay. So this right there, that'll be radius small. This right here will be radius big. Small, big, that's okay. It does feel appropriate that I should use a capital B for the big radius. Okay, so this is the x value. So the x value here would be y equals, y big equals x big cubed. So x would be y to the 1/3. So r big equals, so r big equals x, I'll call this x big, which we know will be y to the 1/3. So what we had to do is we had to rearrange the x value in terms of y, because we need things in terms of y. So this equation, this graph right here, is represented by y equals x cubed. So to rewrite that in terms of y, it would be y to the 1/3 equals x. And this x right here, well, that is radius big. So that's going to be this distance right here, which is the same as the x value, is our big radius. We're going to do the same thing for the radius small. So radius small equals, I'll call it x small right here, x small, which, let's see, we have y equals x squared, therefore y to the 1/2 will equal x, okay? Which will be y to the 1/2. So these are our equations that we're going to use. Okay, plug them into the formula that we have for the disk method, or as I like to say, the disk minus disk method. 0 to 1, move the pi out here. So we have our big, which will be y squared. So it'll be y to the 1/3 squared. So we'll get y to the 2/3 power minus y to the 1/2 squared, which will just be y to the first, which will be y. And we'll have delta y. Okay, not too bad. Then we will do the integral. So y to the 2/3 becomes y to the 5/3 multiplied by the reciprocal, which will be 3/5, minus y squared over 2. And this will all be evaluated from 0 to 1, which will give us pi times, so y to the 1 to the 5/3 will just be 1. So we'll be left with 3/5 minus 1/2. And then when we do the same thing for 0, we just get 0, so that's fine. So we have pi. Now we need a common denominator. I'm going to go for 10. So we'll do 6/10 minus 5/10, which equals pi over 10, or pi times 1/10. Whoop. Move this guy up here. Makes it look like it's a negative. Not supposed to be negative. Click, click. Highlight you. Fine. I'll just move the 10 away. You can stay there if you want. There we go. Gotcha. Okay. Hop. And so it'll be this one right here. So to backtrack, to look what we did, because these things kind of take a lot of setup, and then they kind of get slow to roll, and then all of a sudden it's like, bam, solved. And it's like, I didn't see that happening. That's okay. That's why we backtrack. Look, we recap what we did. So we're trying to find the volume of the shape created by revolving y equals x squared and y equals x cubed from 0 to 1. Here is 0. Here is 1. But it's actually talking from 0 to 1 in the y, so it's 0 to 1 here as well, which is convenient. So what we're doing is we're going to make discs, since this is the disk method, or the disk minus disk, or the washer method. We make a disk for the small circle, I guess, small graph, and circle for the big one, and we subtract the small radius from the big radius. And what we did is we're basically making washers or discs with disc-sized holes in them. And we're going to make these discs, the area of these will be pi r squared minus pi r squared of the smaller disk. Do this from 0 to 1. And we're doing this in the y direction, so it's delta y, because we're doing little delta y's all the way up. Find out what the radius squared is for one value, radius squared is for the other value. And we have to be careful to make sure we have the right, terms, so x's or y's. One of the challenges here then is you could rewrite this as 0 to 1 of pi x big squared minus x small squared. Because you can see this is the x value, the big X value. This is the small x value. And this will be evaluated in the y direction. Well, you really can't evaluate, it's difficult to integrate x with respect to y, because x is a function of y. So what we did then is we refound, this was y equals x cubed. So when we rearranged it, this is y to the 1/3. So y to the 1/3 squared minus y to the 1/2 squared times pi integrated delta y. And this sets us up in a way we're more familiar with. And from here, it's our standard power rule, integrate, substitute in, and then solve. And after we found all that, we found an area, and the area we got was pi over 10. That's the way we approach these kind of problems. Hope this helped. I will see you guys in the next one. Thanks much.